Welcome back. This explainer is brought to you by Forge College. Today, we're diving into unit and integration testing strategies. We're picking right up from our last lesson on transaction forwarding patterns and trade-offs, and now we're going to master exactly how to test those complex systems. Seriously, if you've ever deployed a smart contract and just crossed your fingers hoping it doesn't spontaneously combust, yeah, you're in the right place. Let's get right into it.
Here's what we're looking at today. We'll kick things off with a welcome to advanced testing, compare unit versus integration tests, and then zoom all the way in for unit testing, the micro. After that, we'll zoom out for integration testing, the macro, cover some essential workflows and cheat codes, and finally wrap up with our next steps.
All right, Section 1. Welcome to Advanced Testing, setting the stage.
So how do we prove our code actually works before going live? Look, deploying an untested or just poorly organized smart contract is literally like driving a car off a cliff and just hoping the brakes somehow work on the way down. It's wildly risky. We need a highly structured, reliable way to ensure safety. And that brings us right to the two foundational testing strategies you're going to use inside your Foundry workflow.
Moving on to Section 2, unit versus integration tests, micro versus macro.
I like to think of unit testing as a detective meticulously examining a single piece of evidence in a sterile lab. Integration testing, on the other hand, that's the architect watching the entire completed building function out there in the real world. You absolutely need both. Take a look at this matrix we've sketched out. It perfectly illustrates the trade-offs here. Unit tests have a tight scope on a single module, they rely on mocks for total isolation, they run crazy fast in your pre-commit, and they assert exact returns. Integration tests step it up to multiple contracts. They use real deployments, so they run a bit slower in your CI pipeline, and they're focused on validating end-to-end invariance, which is just a fancy engineering way of saying they make sure the math across the whole entire system actually adds up.
Section 3, unit testing, the micro, the detective's magnifying glass. Let's start with this micro approach. This is where we strip away all the external chaos and just focus on one tiny, measurable mechanism. A unit test is the verification of a single, small piece of behavior run in total isolation with deterministic inputs and outputs. By ditching those messy, stateful interactions and keeping mocks to a minimum, we guarantee that the behavior we're observing depends entirely on the inputs we gave it. No surprises, no random variables popping up. Let's look at a practical example. Imagine a simple financial primitive, an isolated FeeCalculator contract. It has exactly one job. It takes an input amount and mathematically divides it to find a pure 1% fee. That's the whole shebang. Because it's perfectly isolated, if we input 10,000, Foundry's assertion function guarantees we get exactly 100 back every single time. This all happens in our lightning-fast pre-commit workflow. It's totally deterministic and absolutely rock solid. But hang on a second. What happens when our contracts actually need to talk to each other? I mean, a single engine gear works perfectly sitting on a workbench when you flick it with your finger, but eventually we gotta see if it can turn the wheels of the car, right?
Section 4, integration testing, the macro, the architect's view.
As we frequently emphasize in our other developer programs at Forge College, integration testing validates orchestration, not just the individual algorithms. It's about the symphony, not the solo. An integration test exercises interactions across multiple contracts or system boundaries to validate a complete flow and its invariance. Because these tests touch so much more state and expose a lot more possible failure modes, they naturally run slower. That's why they live in your broader continuous integration workflow, not your local rapid-fire checks. Let's see how this builds out in practice by composing a token and a vault. We're going to drop two real contract instances into our Foundry sandbox, an ERC20-like token and a vault that accepts deposits and distributes fees. We can meticulously step through this whole process. First up, we deploy the token and the vault. Second, we mint 1 million tokens to our user, Alice. Third, we trigger a real simulated vault deposit. And finally, we assert all the balances across the board to validate the final system state. So our integration assertions are here to prove the math holds up across the entire ecosystem. Alice deposited 10,000 tokens, which leaves her with 990,000. But if we check the vault side, the vault now holds 9,900 tokens, and the fee recipient got their 100 token cut. We've just successfully verified that both the vault and the fee recipient got exactly what they were owed after that complex interaction.
Section 5, workflows and cheat codes, tools of the trade.
To seamlessly switch between this micro and macro testing, Foundry gives us some incredibly specific tools to control our environment. We call them cheat codes, and honestly, they're basically superpowers. But before we use them, we need to understand why they exist. A deterministic assertion is an expected outcome that stays exactly the same across every single run. Because you never want a test to randomly fail just because you ran it on a Tuesday instead of a Monday, or because a block timestamp shifted by a single second. That's exactly why we have to strictly control the sandbox.
Okay, let's look at the absolute essential cheat codes you need. We have vm.mockcall, which lets us control external contract return data. Then there's vm.startPrank, which we use to simulate calls from specific addresses, like acting as Alice during her deposit. And we also have vm.warp and vm.roll to explicitly control time and blocks. By leveraging these, we force absolute determinism right into our testing workflows.
Section 6. Wrap up and next steps. Building the pipeline.
By strictly separating your fast, deterministic unit tests from those broader, stateful integration tests, you are building an absolute fortress of a safety net for your smart contracts. So where do we go from here? Next up, we'll be consolidating these testing strategies into a basic Foundry workflow. In our next lesson within the Ethereum DevStacks and Frameworks track, we're going to stitch all these tests together into a fully automated continuous integration pipeline.
I want to leave you with one final kind of provocative thought. If a single faulty unit can bring down an entire integration, which test are you going to write first today? Think about your current code base. And hey, make sure to visit forge.college to learn more about advanced testing and to master a ton of other Web3 subjects. This explainer was brought to you by Forge College. Keep building, keep testing, and I'll catch you in the next one.